In this video, we're going to be solving for theta when there's a given range that theta must be in. So in our first example here, we have the sine of theta equals negative 0.25. So the first thing that we need to do is to solve for theta. And so to do that, we're going to need to separate our theta from our sine. So we're going to do some left multiplication, and we're going to left multiply by the inverse of sine. And that is going to allow our inverse sine and sine to cancel each other out, leaving us with theta equals the inverse of sine of negative 0.25. From here, we'll take this, we'll plug this into our calculator and approximate this to 1 decimal place. So we'll make sure that we are in degrees, which we are, and then we'll type in inverse sine of negative 0.25 and hit enter and get a value of negative 14.47. So we'll write down negative 14.5. Now you'll notice that this answer does not fit into our range where theta must be in the third quadrant. And so what we're going to do here is we're going to use our reference angle. So here we have kind of what we're looking at right now. So we have the starting, and we have our terminal side here. And so we want to find our reference angle to help us out because we need to be in this third quadrant here. So to find our reference angle, we're going to notice that because we went negative, our reference angle here that we're looking at is actually going to be 14.5 degrees. So to get our angle into the right place, we're going to go ahead and say, okay, we're going to take the 180 degrees, and now we're going to add that 14.5 to that, which is going to give us 194.5. And we're actually going to go ahead and round this up and say, all right, well, this is going to make our theta approximately 195 degrees to fit into our range, because we'll see that 195 does fit into that range. It does fit into our third quadrant. So let's talk a little bit about why this works or how this works. So notice here on the unit circle that we have pieces that match. Sure, their x's and y's change from being positive or negative, but the numbers are the same. The values are the same. Same here, and even same here. So if, for instance, I wanted something to be in the third quadrant, and when I graphed it, it was in the fourth quadrant, notice that I can get these same values by using that same distance away. So if I can find out what my angle measure is here, I can simply add that on to the 180. So I can go down the same angle amount. Let's get rid of our yellow really quick so we can see this. And that's going to give me a new terminal side. And notice that my values are the same except for positive and negativity, but they live in our range, and so that's been taken care of. Let's try letter B together. So here we have the cosine of theta is equal to negative 7.2. Excuse me, negative 0.72. But again, we're trying to be in the third quadrant. So we write down our cosine of theta, and we're going to solve by left multiplying the inverse of cosine to eliminate our cosines and isolate our theta. That's going to give us that theta is equal to the inverse cosine of negative 0.72. So we'll plug that into our calculator. So inverse cosine of negative 0.72, and that's going to give us a value of 136.05. So here theta is going to be approximately 136.05 degrees. Notice that that does not live inside of our range. So if we take a look at our graph, so we have an initial side here, right? There's our initial side, and a terminal side of 136 degrees. So let's go ahead and let's say that's our purple. So there is our theta. But again, it's not in the right place. We need it to be in the third quadrant. So we're going to find our reference angle. And we're going to do that by taking 180 degrees and subtracting our 136. We'll round this to 136 because 0.05 would round to 136. And we're going to see that that is going to give us a value of 44 degrees. So here we're able to say that our theta prime is going to be equal to 44 degrees. So what we want to do is we want to move 44 degrees in this direction to create our new terminal side to get our values. So we're going to add 44 to 180. So we're going to take the 180 and we're going to add the 44 to it. And that's going to give us a value of 224 degrees. So we're able to say that theta is going to be approximately 224 degrees for our solution. Now again, remember that we were only able to do this because we were given ranges that our theta needed to live inside. Had we not been given those ranges, then we would have been able to say from the beginning that our solutions were negative 14.5 and 136.05, or negative 15 degrees and a positive 136 degrees respectively.